Okay, so the last section of this is the benefits of volcanism. How does it impact us? How does it impact us? We talked a little bit about that last time, because the last section that we talked about is basically how does volcanism affect the development of our Earth. But now we're going to talk about how it benefits us specifically. Okay, so one of the big things that it does is that it can actually provide geothermal energy. So for example, Iceland gets a lot of its power and heat from the subsurface. Now we can do the same thing here. What we do here is we drill large, deep holes and put water down those holes. And when it goes down deep enough, it will get hot. And when it comes up the other, and get another hole on the other side, that hot water can now go back up. And now that hot water can then be used for heating and for things like that. It's geothermal energy. Now they have one that's like that up in Fayetteville. I think Fayetteville State University has one of their dorms actually heated by geothermal. So we can do it here, but it's not. It's pretty expensive here still. That was more of a proof of concept that it could be done here, and it was a big experiment that they did there up there to see if they could do it here, and they did. And now it helps heat some of their dorms up there. But they can do it in other places even better. If you have volcanics in that region, you can even have geothermal heat better, like Iceland. That's a great example of that. California has great hydrothermal as well, geothermal. Other things are mineral deposits. A lot of materials that come from the subsurface are mineral deposits as they come up. And remember, some of them fall down. You have the mafic stuff going to the bottom, the felsic stuff going on the top. Well, a lot of times that mafic stuff that goes down with it is gold, silver, things like that. And so you can have this abundance of these heavy, dense materials towards the bottom of these deposits. So if you can find those deposits, they're great things for that. Now, to find gold and silver and things like that. However, also when you have fluids going through some of these cracks and the hydrothermal fluids come up in maybe these cracks, they might actually bring some of those heavy metals with them. So in those cracks, you tend to have gold and silver and things like that too. So they're great places to find gold and silver and some of our other metals. So, so we get sulfur, gold, copper are all places where we have major ores from igneous bodies. So for example, up near Morrow Mountain here in North Carolina, near Charlotte, we have lots of gold up there. And the reason we have a lot of gold up there is because that used to be a volcanic center about 500 million years ago. And when it was a volcanic center, now it's been slowly eroding away, and we have the veins of materials where the water flowed up into those veins and actually solidified. And there's gold and silver and things like that all over the place. That's why we have a gold rush here in North Carolina. Now, also our ocean chemistry is really important, and some of the nutrients that come out of our ocean floors from outgassing from vents and stuff like that produce the nutrients that a lot of organisms on our planet actually live off of. And some people even suggest that that's where the crucible of life was. That's where some people say these vents in the subsurface underneath the oceans are where the first bacteria on our planet ever formed. Agriculture is great. Agricultural soils are very rich in nutrients. Now, when the ash first comes out, it's actually sterile, which means that the ash is still encased inside the rock. The nutrients are still encased inside the rock, but as they slowly erode away and weather away, those nutrients are released, and therefore the volcanic soils are very rich and very good for agriculture. Our modern atmosphere is here because of volcanoes. That oxygen came from carbon dioxide converted by plants. So that volcanic outgassing, then changed by plants, is where we get our modern atmosphere, so we can actually breathe. I think that's important. Last one is ocean formation. A lot of people suggest that a lot of the water from our planet initially was one big ball of magma. As it slowly cooled off, the water within the volcanoes, the magma itself, started to slowly condense as it was outgassed to form our oceans. So our ocean formation could potentially be because of volcanoes as well. That's one of the hypotheses about where our oceans came from. Okay, so I've already talked about this, where mineral deposits can be concentrated because of volcanics. Okay, but also this is due to plate tectonics. So in places like when you have subduction zones like here, you can get a lot of gold, silver, just like we were talking about just a second ago, copper. Places here where you have magma coming up, you can get lots of chromium, platinum, and so forth. So plate tectonics and volcanics has a great concentrate some of these minerals that we can then use. So some of the materials that we use from igneous rocks that we mine is bulk igneous rock, just like we do this granite for granite countertops, for building materials, scoria for for landscaping, the red rocks, right, materials. You can get minerals from the felsic mineral rocks, so the large crystals inside the rock, you can get aluminum from them. And potassium feldspar, so like some of these, here's one that has some really big crystals in it, and if I mine some of those big crystals, then I can actually get some of the potassium from it, from the feldspar that's within it. All right? Okay. So for ceramics or other things I might get from it, or the muscovite that you can get. So we can get minerals from the mafic rocks, which also can have diamonds in it as well, peridotite, you can mine those for those. If you get layered intrusions, lots of times they might have iron and chromium in them. So we can mine titanium, nickel. Hydrothermal fluids can have copper, silver, magnesium, gold, and then porphyries also can have gold and tin. So these are all things that can come from igneous bodies that we can then mine for our use in our everyday lives, right? So example, hydrothermal, where we get, this is actually the Kennecott copper mine in Utah, where there basically was this big pluton. The magma came up, water flowed through the cracks, water went back up, filling that with copper and other gold and silver and stuff like that. They now mine that. That's where we get the vast majority of our copper in the nation is from the copper mine. It's one of the largest copper mines in the world, open pit mines in the world. Other places you can do it is the thermal mineral deposits on the surface of the ocean floor, where you can get lots of magnesium and lead and zinc. Okay, so the magma contains that water, those fluids. They actually will have lots of sulfide in them, sulfur dioxide, carbon dioxide. And so the problem with this is once they get in that fluid, sometimes they can precipitate out. And as they precipitate out, they have lots of sulfur in them. And that sulfur, if it interacts with water, can actually cause pollution. Okay, so here's some other examples of some of the metals you can get: chromium, copper, gold, lead, aluminum, nickel, platinum, silver. All those kinds of things can come from hydrothermal fluids. However, these fluids often tend to have lots of sulfides in them, or minerals that have lots of sulfides in them. And sulfides, when mixed with water, are not a good thing. So when you break these up into mines, break them into smaller pieces, remember now they can interact with the water better, and so now you're going to have acid rock drainage. So here's an example of one. This is the Ore Knob mine up in North Carolina. It's the north portion of North Carolina, north of Boone. And that area there has a copper mine mostly, but cadmium and zinc and lead from the volcanics that used to be there a long time ago. And they mined that area, and this is their tailings pond. Notice it's all kind of yellowish and orangish because of all the copper and the sulfur that's in the area. And there's having this acid mine drainage issues in this region because of that. These are all mines in North Carolina that actually potentially could have contamination issues in them. So it is an issue that we do have here in North Carolina. Here's another place that happened. This is a kind of one that happened just recently, back in 2015. That was me and some students were actually out on the Colorado River 2 days before this happened. We did not get caught in this, but it happened. But what happened was a mine that actually was broken, and all the fluids all of a sudden flew out of it. That it was closed up, and then over time, all this basically acidic acid filled up, and then somebody was actually there and actually accidentally broke it, having all of it. As the EPA attempted to release the pressure behind it, all that fluid came out, went out into the Colorado River, and had this big pulse of acidic water going down the Colorado River, killing lots of fish. First went down the San Juan, and then to the Colorado, later on to New Mexico, Arizona, and then down the Colorado River. It was pretty bad from what I hear. Like I said, we were on the Colorado River, but not this part of it during this time frame about 2 years ago, and this is just downstream of it, where there's nasty, just yellow water, killing a lot of the local fish. Anyways, so we have good things from it. We can get lots of metals from it, but also with all mining, you can get pollution as well, and you got to be careful with what you get with it. So, anyways, that's the end of the igneous activities slideshow. This one, it's a little longer than some of the other ones. There's a lot more information. It's sometimes harder for people to get it all together, but hopefully you enjoyed it and enjoyed a little bit about volcanoes and igneous rocks as a whole. Okay, guys, I'll see you next time. If you have any questions, shoot me an email or put it in the general discussion board. I've been trying to do better at seeing that. I didn't see some of you guys from last time, but I'm trying to do better at that. Anyways, shoot me a question if you have any. Talk to you later.